to give you a little rock plan. Share my screen. All right. So, all right. So metamorphic rocks are rocks that are created from alteration of pre-existing rocks. So these pre-existing rocks are like the parents, and they are called proto-lithes. Means uh, this means rocks, the proto before. So, so there are two types of metamorphic rocks. There are one is called foliated, one is called non-foliated. The foliated rocks are the rocks that actually show some kind of layering. So it's not sedimentary layering. This layering comes from direct pressure. So when you put pressure on something, like a pen, the pen becomes that's a foliation. So if you start with a very with a sedimentary rock like shell, under so up to 200 degrees Celsius, that's the window for the sedimentary rock. It will still survive as a sedimentary rock. Then it will start to yield to this pressure and temperature that is being added. So, and new minerals will form in response to this additional pressure temperature. So if directed pressure and temperature both are present, a shell will become a slate will become a phyllite will become a schist, and schist will become a gneiss. So with progressive increase of temperature and pressure, and the minerals that will form will define these rocks, but all the rocks will have some kind of foliation or layering. So in the foliation that is in slate is called slaty cleavage, in schist is called schistosity, and in gneiss is called gneissic banding or gnissosity. And at the very low grade, you will have very small fine grains. So a slate almost looks like a shell, only much hardened. And then by schist, you have larger minerals growing in it. And gneiss, you will see the gneissic and calcic banding, like a zebra banding in the rock. Okay, on the other hand, if you only have temperature, high temperature from let's say a magma intruded into the rocks, all the surrounding rocks are now going to experience additional heat radiating out from this magma as it tries to cool. So all around the magma chamber, this heat, but there is no pressure involved. So it's mostly due to heat. So whatever rock is present is going to yield to this new pressure and new temperature conditions or heat conditions. So if you had a limestone, which is only made up of the mineral calcite, these calcite grains will just kind of readjust themselves and grow, recrystallize into a bigger grain. So there would be no foliations present. If you had a sandstone, it will become a quartzite. So these are monomineralic rock, means one mineral makes the rock. In calcite is the mineral, in limestone, quartz is the mineral, in sandstone. So they will make the rocks marble and quartzite. That's called the metamorphic rocks. And anthracite is the coal version of metamorphic, what we call metamorphic coal. So it comes from the coal that we call bituminous, which is sedimentary in origin. All right, next we go to look at the foliated rocks. So these rocks are slate, schist, and gneiss. You can see the slaty cleavage in the slate. So you look carefully, look with your lens, and you will see layering. It's very fine grained, very smooth. The rock that has just been transformed from a sedimentary to a metamorphic rock. You go to the next rock, which is schist. If you go to the next rock, the schist, like so, a shell. So here's a magma that has intruded, or this is a mountain building event happening where there's additional pressure and temperature. A shell becomes a slate, becomes a phyllite, becomes a schist, becomes a gneiss. So here are three examples: slate, schist, and gneiss. I'm not going to talk a lot about phyllite because that's not in your hand samples. So these are the three rocks that you have to identify. So look in this rock for some kind of layering or foliation, and the finest of them, the smoothest, will be slate. The ones that you will see visible minerals in it, that are shiny probably, that should be a schist, and the one that is banded will be a gneiss. All right. Now, non-foliated rocks, as I said, around the magma chamber. So if there's an igneous intrusion like granite, all the minerals will be, all the rocks around it will be metamorphosed. So you will get a rock. All the rocks here would not have foliation. So like quartz will become sandstone will become quartzite. Only the quartz grains will become larger. Calcite, calcite in limestone now will crystallize into like calcite in marble. And coal is this is the only rock that might show some fine grained layering, but it's going to be very light in texture, and it looks like it has a punctured fracture and glassy texture. Sandstone, on the other hand, how to we're going to identify sandstone is made up of quartz. So sorry, quartzite is made up of quartz, which is the parent rock of quartzite is sandstone. Both sandstone and quartzite is made up of quartz, so they both will scratch glass. So take your rock, scratch glass whenever it can. Now, if it's a very smooth surface, it might not be. So make sure you use a little bit of broken edge to test any of the minerals you are testing for. So quartz, break a little piece, make it a fresh surface, and then scratch on it. Calcite, again, break a piece of it and test the acid. And wherever you see bubble, the calcite bubble, that's going to be marble. So you have marble, quartzite, and anthracite, the three non-foliated rocks. So here is your table. So I've created this table from if you just can write this after you have identified your 6 rocks, M, N, O, P, Q, R. 3 will be foliated, 3 will be non-foliated. Grain size in the foliated rocks goes from fine to medium to coarse. What are you looking for in these rocks? Smooth, dull surface for slate, visible sparkling mica for schist, and light and dark colored banding for the gneiss. So what are the minerals? Slate is hard to tell, but you will have these mixed minerals. Some of these minerals you might see in the schist, and some of the minerals that you will see in the gneiss or the metamorphic minerals will be amphibolar biotite, and felsic mineral will be muscovite, feldspar, and even sylvanite. Now, what are the parent rocks? All of these rocks are coming from the parent shell. Now, for gneiss, it can also come from granite. So looking at a gneiss, you cannot tell whether it came from a shell parent or a granite parent, which is kind of a little crazy. One is a sedimentary rock, one is an igneous rock, and they can both serve as a parent and yield a gneiss at high pressure and temperature. On the non-foliated rocks, you have 3: anthracite, marble, and quartzite. Again, I told you what they are. You are mostly looking at carbon, very light, very dark, and it has a glassy texture. And the limestone, which has become a marble, has calcite in it. So all these 3 things will actually fuse with acid. Again, break up a small piece of the edge and test the acid on it. And quartz, whether it's in quartz or quartzite or in sandstone, they are all going to scratch glass. So whichever rock scratches glass will have quartz in it. And so these are your 6 rocks. Pretty easy. So again, 3 foliated, 3 non-foliated. Don't write any other rocks. And then the protoliths for the non-foliated rocks are for anthracite, bituminous coal, for marble, limestone, for quartzite, quartzite, sandstone. So this is the table that you have to do for your lab. Pretty simple. Just write these, and that would be it. I want to very quickly tell you a little bit about how the grading changes. So as you go from farther out from the magma intrusion or farther away from the active mountain building where mountains are colliding. Now the question is, where do you see this mountain, these rocks forming today? Don't give me an old mountain chain. I mean, yes, there would be gneiss in Georgia, but that's probably a billion years old. Where is this forming now? So they're forming very deep in the earth, away from our feet, below our feet, or it's forming where a new mountain is forming today, where 2 plates are colliding, 2 continental plates are colliding, a huge mountain chain is going up. That's how these rocks were formed. When the Appalachian forms in Georgia, you have some gneiss that are that old. So today's gneiss is not forming in Georgia, it is there. But today we have gneiss that are forming in active mountain building what is going on. So again, it shows you that granite intrusion, if you have different sets of rocks present from the intense heat, shell is present, it will go through these progressive changes into slate, phyllite, schist, and gneiss. If you have sandstone present, it will become a quartzite. You have a limestone present, it will become a marble. So that's for the sediment metamorphic rocks. And do your lab. And if you have any question, ask me later. Bye.